Okay, we're going to look at all the power laws that we talked about the other day, but now with variable bases. So nothing changes except the base is not a number anymore. We will look at some that have numbers and variables as well. So here, try to do these without a calculator. The numbers aren't going to be too big, so you should be able to. So first one, simplify each of the following. If you take a look at this, you're multiplying powers with the same base. So that means you add the exponents. 3 plus 4 is 7. The base remains the same. Next one, you're dividing. So the base remains the same. You subtract the exponents. It's 2. Next one, you're dividing as well, but it's in fraction form. Be aware that the exponent on n here is 1. If no exponent is shown, it means an exponent of 1. So now when we subtract those exponents, we get 4. So n to the exponent 4. If the base is in brackets, then that's fine as long as the brackets are exactly the same inside. So test out the inside here is negative b. So copy it out. The base stays the same, and you would add the exponents. Now this one, because there is a negative inside the base, you could actually simplify this a little bit further. You know that anytime you have an even exponent on a negative base, it will end up being positive when you evaluate it. In this case, when you simplify it. Next one is power of a product. So we did numbers yesterday. Now they're variables, but remember that 7 applies to every factor inside there. So that's going to be x to the 7, y to the 7. Power of a power, it's like having ones there. You multiply the powers together, the exponents together. Next one is, again, a power of a power. So you multiply the exponents, so that's x to the 10. Now we have a few more variables. So we have two brackets, x squared times x to the times y cubed. Then in the other brackets, x to the 5th times y to the 7th. Really, we could show that as x squared times x to the 5th times y cubed times y to the 7th. You don't have to do that. As long as you look for powers with the same base, then you add the exponents. So that's going to be x to the 7, y to the 10. Same with this next one. So really on this side, we've got the m's, and this side we've got the n's. So we can simplify those. So when you don't have an exponent, remember it's a 1. So that's going to be m to the 11 times n to the 1, which we don't even need to show. Right? It's understood to be a 1. So we can keep it as n. Next one we have to consider order of operations. So I remember it this way, brackets first. So within the brackets, there is nothing to do. Then exponents, that would be this whole thing here. So we need to do that first. So power of a power, you multiply the exponents. Then you can do this all at once, or you can simplify the numerator. So that would be n to the 10, because you're multiplying powers at the same base. And then you're dividing. So that's going to be n to the 7. You subtract the exponents. Okay? If you wanted to, you could do it all at once. It's really you're going n to the 6 plus 4 minus 3, which is n to the 7. Okay? So let's get into a little bit more. Let's look at the power of a product. I just copied this from your other chart. So 4 times 2, all cubed. That really means you have 3 brackets of 4 times 2, which really means you have 3 4s multiplied together and 3 2s multiplied together. Okay? So when raising a product to an exponent, raise each factor in the product to the exponent and then multiply the powers. So here in general, that's a to the m, b to the m. So here, that's 5 to the 4 times 2 to the 4. All right? Now, if there's numbers and variables in the bracket, same thing. So notice here, these 4s are the same. So that's why these are both 4 cubed. But now instead of a number, we have x. So that means it's just going to be times x cubed. Now the thing from there, in these ones, we do need to simplify. So 4 cubed, really all of them you'll be asked to evaluate, sometimes just simplify, but in this case, when it says simplify and you have numbers and variables, you need to evaluate. So 4 cubed is 64, x cubed. So this is the same definition. So here, m refers to the 3 and to the x. And so this example here, this is 5 to the 4th, y to the 4th, and then you evaluate the 5 to the 4th. You need to do that. So 5 to the 4th is 625, y to the 4th. If you needed to use your calculator for that, then that's okay. All right, so let's practice. So same as the last one. This is 2n to the 4th inside the brackets, and we have to raise all of that to the exponent 3. So that means 2 is raised to the exponent 3, and n to the 4th is. So when you multiply those exponents, you get 12. Then evaluate 2 cubed. Well, that's 2 times 2 times 2, which is 8, n to the 12th. Okay. If there's a negative, keep it inside brackets. You don't want to mess up the negatives. So negative 3 to the 4th, x to the 24th, right? Because that's like a 1 on that exponent, okay? Then evaluate that. Well, even exponent on a negative, that's going to be positive. 3 times 3 is 9, and you've got 2 pairs of that. So 9 times 9 is 81. If you're trying to do it without a calculator, you need to think of strategies to help you. Next one, the coefficients, so 2 to the 4th, and then each of the variables, so x cubed raised to the exponent 4th, 4 is x to the 12th, y to the 4th is y to the 4th. Okay. Next page. Okay, simplify. So this, in this case, we're multiplying and dividing in a lot of these. So you need to realize that those coefficients are just numbers. If we didn't have the n's in there, it would just be 2 times 5. So that's our coefficient. We do have the n's in there, so then we just, so really this is 2 times 5 times n to the 4th times n to the 8th. You kind of group them. So that's going to be 10 n to the 12th. Multiplying powers with the same base, you add the exponents. Multiplying again, 2 negatives make a positive, so that's 15, and then adding the exponents on the common base of x, that's 13. Okay, then 4 times 8 is 32, x cubed times x to the 4th is x to the 7, y times y to the 6 is y to the 7, right? That's like a 1 there. Okay, so it's not, doesn't say it's y to the 6, you're multiplying it, so be aware of that. Okay. Then dividing, same thing. If we didn't have those there, 24 divided by 6 is 4. But we do. So take a look. X to the 17 divided by x to the 4. Well, you subtract the exponents, so that's x to the 13. Okay, and then the next one, that's 5m, nothing to do in there. In the next bracket, there's nothing to do inside, but we have to deal with the exponent here. So that's going to be 2 cubed times m to the 9, which really you can go straight to 8m to the 9. Then multiply the coefficients, that's 40. M to the 1 times m to the 9 is m to the 10. Next one, we've got big brackets, lots to do inside there. So think of order of operations. We have to, so if I have my order of operations, I should do inside the brackets first, okay? You can, in this case, actually deal with the outside exponent, raise everything inside to the exponent 2, but that's a lot of work. So if you follow the order of operations, we keep our brackets. Inside this division question, we get 3 x cubed y squared, okay? Then that 2 stays outside, so we're doing inside the brackets first. Now we'll do the exponent outside, so everything gets raised to the exponent 2, and then evaluate the coefficient in front, okay? Next one, we're dividing again, but notice how here 12 over 15, we didn't have that. It doesn't go in evenly. So you want to reduce it just like you would reduce any fraction. So 3 goes into 12 4 times and into 15 5 times. Okay, so we'll have 4 over 5. And now, really, we do have the x's, so we got to keep them in there. And we're dividing, so we subtract the exponents. So that would be x to the 17. Okay, so that keeps it in fraction form. You could also show it as, so I'll put 4/5 x to the 17. Okay, it means the same thing because that's really like x over 1. Okay, so just be aware, either works. Next one, again, order of operations. Inside the brackets, there's nothing we can do. So next is exponents, and so we have to figure out that first before we do our dividing. So here, that's going to be 6 squared x squared y to the 8 over 36xy cubed. 6 squared is same as 36, right? So you could go straight to 36. So here to here, and now 36 is divide out, right? And then x goes into x squared once, y cubed goes into y to the 8th, y to the 5th times. You're subtracting those exponents. So that's going to be x, y to the 5th. All right. And then the last one, order of operations, nothing to do inside each of the brackets. No exponents on the brackets, so then it's division, multiplication, addition, subtraction. And there's no adding and subtracting in these. So what I recommend is that you actually figure out everything. This is kind of like having big brackets here. So I recommend that you figure out, do the brackets first, right? FEDMAS. And so that whole numerator. So that's going to be 48 n to the 5th, n to the 7, over 12, n to the 5th, oh, sorry, m to the 5th, n to the 7, and then you can see 12 goes into 48 4 times, and notice how these are exactly the same, so they go in once. 4 times 1 times 1 is 4. If you were to use your power law, subtracting the exponents, you get 4 n to the 0, n to the 0. You need to simplify that. That's 4 times 1 times 1, which is 4. So you might as well just do it right away. Okay, so that's power laws with variable bases.